So we can open this session of questions and comments.
Yes, sure.
Usually we start with the reviewers. So we start with Edita.
Sure. So I guess the questions are in English or in French.
As you like.
So, as you want.
You're welcome. I'm very happy that you could participate.
All right. So let me go in English then. Okay. Yeah. Thank you very much. Great presentation. Great slides. You had some nice graphics. So it was a great summary of your work.
Thank you so much.
So just a couple of questions. Let me see. Well, actually, I'll just start with the end. Yeah, can you go back to slide 40? Sorry, I'm kind of starting from the end, but
It's okay.
might be easier. So yeah, it's more a question about the
This is 38.
40. Yeah, this one. Yeah. So basically, it was just a question about. So you mentioned cybersecurity as the application. So yeah, so I'm going to ask a question specifically about cybersecurity. So of course, anomaly detection and so on. It's very different depending on the application. So okay, so we look at cybersecurity. So for example, when you say fast detection, so can you clarify exactly what you mean by detection? And in particular, yeah, basically there's the training time and then the sort of inference or prediction or what I would call detection time. So yeah.
Sure. Sorry.
Yeah, sure. Go ahead. Yeah. So you want to answer the question?
When we talk about detection time, we talk about the whole process from actually processing the data until the detection, until the test, or the whole process. Because as I said, in our application and our SWAR, the platform that detects anomalies, this is our aim. We want to connect it to real-time data and actually to go from the training for a continued training in the same time until the detection. So when we talk about speed of detection, we talk about the whole process, from processing, detection, and everything.
Okay. So yeah, okay. I'm gonna push back a little bit on that, but so for example, what's the size of the data set you're looking at, like this US NW?
This one is 2 million samples, and basically in papers when we work on it, we use just the balanced part, but we use the whole data set with 2.6.
So what's the size of the data in gigabyte or in some units like that? It's small.
Yeah, I think it's almost 2. Actually, it's 10 giga with the whole files, but actually after splitting the data into tests, and I think it's 2 giga for the train.
Yeah. So my point is, well, so yeah, this is where the cybersecurity. So of course, it depends exactly what you mean by cybersecurity and exactly where you apply this. But in cybersecurity, the data sets are absolutely enormous. I mean, you may have I don't know, 100 gigabyte to 1 terabyte per day, and maybe you want to process several days or several weeks. So it's huge data. So usually so I see what you're saying about fast detection, but in practice, you really cannot in real time train your model and predict, because you want a response. I mean, the end-to-end response time should probably be in the range of minutes, maybe 15 minutes, 10 minutes. So your algorithm probably needs to process things in seconds or 1 minute, but that's for a huge volume of data. So you have to really the prediction should basically be as fast as possible on large volume of data. So then I want to ask again, let's say that this was the context and you wanted to have the fastest prediction, and you allowed yourself to separately train, offline to some extent, but of course, maybe you want to retrain your model every day or maybe once a week, and then you want to have rapid prediction on on large amounts of let's say you have 100 gigabytes to process every day or something, and this is the volume of data you want to make prediction on, and you'd want the answer within a couple of minutes. So can you comment on that, or how would you? Yeah.
Actually, exactly. We thought about also an offline training. We thought about it because now, as I said, it's a continued training and it takes 15 seconds with the last 50 seconds. No, 15 with the last version. So for like 2.6 million records. We didn't try it in real time yet in the company, so we don't know how it's behaved when we talk about billions of data. That's true, but actually the aim was to take into account this and to try to do something for continued training, or at least if it's not going to be really applicable for continued training, at least actually to do it as you said, once a week, or once a day, or whatever. But to try to have a detection time which is the maximum possible. So this was the aim, because actually, as I said, at the end, we didn't try it in the company because we hadn't time enough to, and we hadn't also enough data, because this was the biggest data set we found for cybersecurity, by the way. So this is why actually we did, or this was the aim. But as you said, yeah, you're right about the bounds of offline training. And actually, this is what's done actually in some applications, except Apache Kafka, but it's not really good in detection. But yeah, right.
Mm-hmm. So you don't have access to real
no,
to real data for your thesis. Okay.
No, we
so
tried.
The other.
The company tried to contact Compustiver to have more data, real data, connected data, but we haven't at the end. But this was the aim exactly at the end, to apply it in real life to see how it would behave. But we hadn't access to data, especially in cybersecurity. It's a sensitive domain, so it's so hard to have data.
No, of course, yeah, it's very difficult to have data. Yeah, no doubt. So I mean, my other question is more. It's maybe that's a research question, just more a question about parallel computing. But how would you define, like, what are the similarities and differences between HPC, cloud computing, and say grid computing, for example? How would you contrast? What's the similarities and differences between HPC, cloud computing, and grid computing?
Okay, so you are talking about HPC, so you are talking about hardware, and you are talking about the cloud, where the data centers. When you talk about
cloud computing in general, yeah. I mean, yeah, it could be a data center, or, I mean, cloud computing, yeah.
So to talk about the similarities, I'm going to say it's kind of hard, because for me, in my opinion, it's data centers are more for stocking data, but for when you talk about the hardware, it's to use or process this data. As I said, this is my opinion, so I can't say that it's sure. But for when we talk about data centers, we don't really specifically talk about data processing now. What do you think?
It's more of a question for you, but usually HPC, I mean, let's say HPC versus grid, for example. So the difference is usually in HPC, it's high performance. So typically you spend a lot of money on, your network, high performance network, and maybe you want a high performance, file system that's yeah, can process very quickly across a large number of nodes. So let's say the grid computing is more about the embarrassingly parallel computing, in the sense that, okay, you just have a lot of processing components, a lot of hard drives, but there's not too much communication between the nodes, right? So your network is just not necessarily a very high performance or expensive network. So in the context of cybersecurity, most companies, HPC of course is very expensive, because the network, to have a very large scale, computer with a fast network is very, very expensive. So usually, the network is not that fast. So yeah, so in the context of cybersecurity, my point is it's more about, let's say, grid computing or even cloud computing than HPC. And in fact, to some extent, the methods you described are there's some communication, but it's probably not like when doing scientific computing, or doing I don't know, like solving PDEs or doing molecular dynamics, where you have really a lot of communication. So here, like it's asynchronous, parallel. So I was curious, can you comment on for example, volume of data you need to exchange, or would this actually work on grid, or let's say just a cloud, versus actual HPC, where you really need a high performance, very, very expensive network?
I'm going to say, if you are talking about our framework, how it will handle this, or the amount of data,
the UC2B, UC2B asynchronous parallel code.
Then I can come back to this figure, where, for example, we had here, as I said, 2,000,006 instances of data. And in the first iteration, actually, the communications, or the instances, misclassified instances, was only 7,000. And I can say that when we are talking about a data set of 2 million, and we have only 7,000 that will communicate, I think that it's not really much. And then at the second iteration, only because actually when we make the command set communicate, we only share the misclassified instances, because we know that they are actually the minority. So to not if we share also the dual classified, it will give they will be costing communications. They will be thousands or millions of communications, since we are talking about millions of instances of data. That's why actually with the restarting function that we use, we only actually share the misclassified, where we increase the weight, and we can see that with iterations of uniting code, it decreased actually significantly. So after iterations, we leave communications step by step. So if we have, for example, thousands of communications, after iterations, we will have only 100. So I don't know if it really adds.
So yeah, I mean, just I don't know. In your opinion, would this work well in the cloud then, or does this actually require Fugaku, which there's only one in the world?
I didn't try, but we used actually Rush from Mesocentre, and also we used Fugaku. So I think since we used different architectures, in my opinion, I think that it could work.
Okay. So let me see. Well, I guess my last question. Well, okay. So actually, can you go to slide 28, where you were looking at the results of various methods?
28. Yeah.
Yeah, slide 28.
Yeah.
All right. This one here. So sorry, it's very hard to read on the screen here. Actually, hold on. Let me open up on my slides, because I can't see your screen right now. It's the contrast, the colors are not showing up correctly. Hold on, just give me a second. Right. So if you look, the green is iForest.
Yes, exactly.
Right. So actually, okay, hold on. That's right. So yeah, I mean, actually, that's another Well, it's more, a question slash comment before asking my question about iForest, which is that, detecting, anomalies in cybersecurity data sets is very difficult because, you have, a tremendous number of, random fluctuations, like, people doing odd things at odd times, but they're not, an actual cybersecurity concern. They're just doing something unusual, but there's no, it's not actually a cyber threat. So the main difficulties with anomaly detection is, this false positive, right? Like you get an alert, you get a signal, but it's not really, it's not really meaningful. So that is the main, the main problem with anomaly detection, and that's why, anomaly detection right now is not used a whole lot in cybersecurity because, nobody knows how to reduce these false positives, and so it's still very much based on, looking for known threats or, using rules and whatnot. So here, for example, the detection, your accuracy is extremely high. I mean, 0.999, or I don't know how many nines, it's almost perfect. I think, in fact, in one of your tables, you even have 100%, correct prediction. So okay, I mean, of course, it's very hard to, have realistic, cybersecurity data set. But I was wondering if you had benchmarked, your algorithm against data set that are more challenging, because basically, this kind of accuracy is not realistic. I mean, in practice, you're nowhere near that level of accuracy because there's a tremendous number of false positives and, wrong alerts and whatnot. So I was curious if you had tried other data sets, or if you have some, I don't know, some thoughts or comments about that. I don't know.
No, we didn't try other data sets, but just want to comment on the fact that you say that it's actually not really realistic for such a actually application, because I have read the paper you sent to me in the report, and actually I just want to emphasize that, for example, in the reports when they in the paper when they say that it's not really realistic for real world, this is because they used a balanced data set. Actually, they didn't use the 2 million that six. They only use the part of the data set. I can show you. I'm just gonna look for the paper. Yeah. So here we can see that they said that actually they use 56K for trained and 37K for test, and it was balanced data. It's not the case for us. That's why they said actually that it's not really adapted to real world application. But for us, we used actually the imbalanced data with the 2 million
Okay.
And also, I just want to show you that actually our data set, actually it contains 87 normal instances and 12% actually anomalies. And this is, I'm going to say, real application, because we can talk here about rare anomalies, because we can't find attacks everywhere or every day. And this is actually the security. But we use actually the normal data with this labeled data and with this percent. That's why actually I can say that it's real to real life. Maybe it's not really real life application, but it's real to real data application.
Okay, all right. So just give me a second. Yeah, I think these are all my questions for now. Okay, yeah, thank you very much. Yeah, great work. Yeah, thank you.
Thank you very much. So we can move to the second reviewer. No,
thanks, President. First of all, I would like to thank supervisors for the invitation to be part of the jury. Yeah. And I would like to thank you, Zineb, also for your last presentation, which reflects the quality of the manuscript. It's clear, pedagogical, and well illustrated.
Thank you so much.
So regarding the contributions, I particularly like the use of the synergy between artificial intelligence and high-performance computing to deal with the challenges of anomaly detection in large and complex data sets. This is the heart of the thesis. I use it in my research works
Oh,
to
great.
address big optimization problems.
Okay. Cool.
So exploring this idea requires various expertise in different fields, including statistics and machine learning, high-performance computing, and to a lesser extent, graph theory and linear algebra.
Exactly, that's true.
And this expertise is, for me, reflected in both your depth analysis of the state of the art on the topic and your contributions, which are, for me, original and open up promising perspectives.
Thank you so much. Later.
I also appreciated the incremental methodology which is used to design the framework, including different variants, ranging from the sequential version to the version which includes advanced graph-based methods, going through the synchronous parallel version and the asynchronous parallel version. So for all of that, I would say bravo and congratulations.
Merci beaucoup. Thank you.
Let me come now to the
to the questions. Okay.
to the questions.
Okay.
So I have while reading the manuscript and writing the report, I noted a list of questions.
Okay.
Some of them asked by Eric.
Okay.
I still have some.
Okay, sure.
The first one is related to the sequential boosting scheme.
Yeah. I go back to it.
Could you come to the slide 28?
Okay.
With another question than the
28,
question
not 18.
28 or 18?
Do you want the framework or the results?
It's okay.
Okay.
Yeah, it's
Sure.
simple.
Great.
Yeah, I have a question which is related to the order in which you apply the models.
Okay.
Does it matter?
Actually, to be honest, no. We just use actually random models to see actually the result that we will have. But in cases where we know that we have, because actually the aim of boosting, because here we are inspired by boosting. The aim of boosting is to boost weak learners. So it's better to start actually by good learners or strong learners to boost actually the weak learners, which will be actually the last one. So it's a good idea if we start with it. But for us, since we wanted actually to try it on all the combination that it should work for everything, we just changed the order randomly without. But yes, it's a great idea, and the order can play a good role here, because this is the aim actually of boosting. Yeah, sure.
I have another question which is related to the asynchronous version.
Okay.
The version is multi-level.
Okay.
You used
multi-level parallelism, yeah.
Multi-level parallelism,
yes.
Including multi-bag, multi-model,
exactly.
values.
Yes.
I would like to know how did you calibrate the parameters of this multi-level parallelism? For instance, the number of bags.
Okay.
It is always fixed to 10 in the manuscript.
Actually.
And how do you fix the number of models?
Yeah. Actually, the number of bags actually was we tried with 10, and then we tried with 30, and we remarked that actually the model doesn't learn efficiently when we increase the number of bags. That's why we set it at 10. But yeah, we tried with 20, and this also doesn't allow us to I'm gonna say. Take advantage of the whole node, because in the whole node, for example, in Fugaku, it has 48 core. So if we use 48 bad, we will use the whole node. But when it comes to learning, it will not give a very good accuracy. But we can use the whole node and all the core if we have a bigger data set, as Mr. Grubbs said. So it will be really, we will use the resource efficiently, and we will actually have, because if you have a bigger data set, even if we increase the number of bags, we will have a very good learning. Because when we split it inside and with models, it gives just a small parts of data, which means that the model doesn't learn enough. And about, you asked also about the methods. Exactly. The number of methods, when we talk about, for example, the sequential, we are talking about the parallelized version. When we talk about synchronous communications, then it's better to increase the number of methods. So it depends on the data nature, the problem, the application. For example, if we use for cybersecurity 4 methods, we will not really use it for manufacturing. Because for manufacturing, we have small data sets, so maybe just 2 methods will be enough. So that's why it's adaptable to all problems and all applications.
They have another question which is connected to this one.
Sure.
In your experiments, the number of models is fixed and determined manually.
Yeah.
What do you think about the idea of making it automatic and adaptive? It could be fixed dynamically using, for instance, some reinforcement learning mechanism.
Exactly.
About this?
It's a very great idea, because our aim here with UC2B is to generalize it. Actually, we make it dynamic or static. It depends on the data here, because we are working in cybersecurity. We actually fixed it to, I'm going to say, adjust the accuracy, because sometimes when you increase it, maybe it will impact the accuracy. This is why we adjust it. But yeah, it can be dynamic also. That's, as I said, to the problem and the application.
Because this is a critical parameter.
Yes, exactly.
You can imagine kind of portfolio of models in which we can select dynamically the models according to their performance.
Exactly, yeah.
We have another question which is outlined in my report, which is related to the fault tolerance. Fault tolerance.
Fault tolerance. Yes.
You mentioned
I remember
several times that fault tolerance is inherent to the proposed methods, but how do you deal concretely with the failure of single model or multiple models?
Yes,
this is very important, especially in the synchronous context.
Yes, and it was also in your report. You said, why didn't you add a figure with testing the fault tolerance? That's true. Actually, for the fault tolerance in our case, it was just when one of the commands stops working and the whole framework continues working, and it gives accuracy until the convergence without any impact, without any problem. But we didn't do the experiment to stop by purpose one of them or two to see what it will give. But it happens that one of them stops working and it doesn't impact the whole framework.
Even in the synchronous context?
In the synchronous communications, it doesn't happen.
Because you have
communications between them. Yeah, this happens in the asynchronous communications. You're right, but as I said, we didn't do exactly the experiment in both contexts to see effectively what it is. But it's.
Okay. I have another question on the synchronous version of the framework. Did you evaluate how the faster models impact the performance?
You are talking about the accuracy?
Slower ones, yeah.
You are talking about the accuracy when you talk about the performance?
Accuracy.
Okay.
Performance in terms of accuracy.
Okay, so I'm going to say that the rapid ones give good accuracy because they do several iterations. Because the last one, the longer one, for example, will do only 2 iterations, when the faster one could do 4 or 5. That's why actually the accuracy for faster are good than longer.
What is the contribution of the slower ones?
The slower ones, I have a figure here about, for example, the methods that could be used, for example, from scikit-learn. We have some of the methods that can detect actually anomalies that others can't detect. For example, because as I said here, we have unlabeled data. We have actually we have anomalies that change the behavior, sophisticated anomalies. So even if sometimes we say that actually the longer word doesn't serve for anything, but when we remove it, when we take it, we have some anomalies that aren't detected by others. So that's why actually a combination of all of them, this is what actually we tried to respect in our framework. In all the experiences we did, actually we tried to choose one of all of them, to try to combine them. Maybe once we'll arrive to detect some others that others will not, or other models will not manage to detect.
So it would have been interesting to highlight the impact of this.
Yeah.
To show the interest of using diverse models in.
Exactly that. Yeah.
We have a question which is related to the way you have evaluated the performance. Okay. How did you fix the time budget? The time budget, execution time.
Okay.
Because to get a fair comparison between the different versions, you have to the version which uses multiple models, the version, for instance, which uses a single model.
Exactly, and also
if you want to get a fair comparison between the two approaches, you should use
the same circumstances.
Allocate the same time budget.
Exactly. For example, we did it. Actually, this is why when I said that it's not really a comparison, but we went from 10 days to 15 seconds, I said that it's not a comparison, but because exactly, it's not going to be a fair comparison because it's not the same resources, it's not the same architecture of the framework. So yeah, you're right. But when we talk about comparison, for example, we can talk about, I'm going to say, and also increasing the number. So we can't in the perspectives. So yeah, for example, here with synchronous and asynchronous communications, going from 26 minutes to 4 minutes, that's 5, we use the same resources. We use Fugaku with 40 nodes for all of them, with the same command. With synchronous communications, it takes 26 minutes, and with asynchronous communications, it takes 4, that's 5. That's why I put them in the same slide to compare them. Because it's the only, I'm going to say, fair comparison that I can do. Here, yeah, so, but because it's the same hyperparameters, the same models, the same everything. But for others, no, you're right, we can't compare them. It's not going to be a fair comparison, yeah. Using one node and going to 512 nodes, yeah. That's true.
Because doing a fair comparison will allow the single model approach to perform more iterations. Yeah. Maybe there's room to improve the accuracy.
Sure, yeah, exactly.
I have a small question. Could you come back to slide 22, please?
22? Yes, sure.
You mentioned the SOAR platform.
Here I am in 26. Yes.
Yeah, I have a question which is related to the SOAR platform. Yeah, it's in your manuscript. You mentioned this in the beginning of the manuscript, and I didn't find the implementation details in the end.
That's true, because as I said, we wanted to actually release products in the company to use it with the SWOR that we have in the company, but we hadn't enough data and we haven't at the end time to do it. That's why it's the objective. But that's why we actually developed the framework, taking into account this, but we didn't really do it. That's why we added this in perspective. We said that one of the generalization is to apply it in the real life in the numerics company. So it was in perspectives, but it wasn't in the end of the manuscript because we didn't did it actually for the lack of data and also time.
I have a last question.
Yes.
In the slide related to conclusions, please.
Yes. Okay. Conclusion. Yeah. So the contribution summary or perspectives.
Not this one.
This one maybe.
Not this one.
Maybe before here when we are talking about the finding.
This one. This one. Okay. Yeah. When you get to look on the accuracy here, it is close to 100%. The challenge here is to gain, small, very small improvement.
Yes.
And in some fields like cybersecurity, this small improvement would be highly important.
Exactly.
So, can you comment on that?
Yes, exactly. That's why actually, even if we had 99.5, we continue improving it. Even if this was the maximum that we achieved, but we have to not forget that this was the parallel version. Because yes, if we have a false positive or false negative in the SWAR, if we have a trait that wasn't detected, it's going to infect all the machines. And also, if we have false alerts, it's going to submerge the machine or the system. So yes, that's why we are really talking about that. So even if for other domains, it seems a very high accuracy, very good accuracy. That's why when Mr. Darv talked about the accuracy in cybersecurity or for our application in the company, if we are talking about 0.001% that's not detected, it's going to be a big problem. That's why we are talking about the comma after for the detection.
So thank you so much for
You're welcome.
contributions to the presentation.
Thank you so much.
Thanks,
Thank you, Martin. So we move to the examiners and to Fabienne first.
Thank you very much. I think I will repeat things. I'm also very pleased to be here, and I was very pleased to read your document, which is very well written, and I learned many things.
Thank you so much.
And also, I did appreciate very much your presentation. You were very at ease, and it was very clear. Thank you very much. Some of my questions have already been asked, so sorry, I have only silly questions that remain.
Pleasure.
So, the first one is, so you use several methods or models.
Yeah.
Do you use them as black boxes, or could you try to do something with them? For instance, if they are iterative, could you act on the number of forward or backward passes? Could you do something with these methods?
Yes, actually, this is a good question. We used them as a black box. We didn't change them. That's why when we improve the research conditions, we talk only about data. We charged only the weight of instances. So why did we do this? To make something actually generalizable, working for everything, without actually looking to improve the methods in them. We make collaborate methods as they are to improve the whole convergence inspired by Unite and Conquer. So that's why exactly we use them as black box. So actually the framework, the fact that we combine them or the way we combine them should improve without touching on hyperparameters or improving the model itself.
And I had another question that I think we answered on your slides.
Yeah.
So each method is run on one node, and what you use is multi-threading.
Yes.
Okay. 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 I have another question.
Sure.
So when you have your node-based dataset partitioning variant, each bag is replicated, and then you go to the asynchronous version.
Exactly.
Was it possible to test the asynchronous features on the previous version? I mean, the version where the bags are not replicated.
Okay.
Is it possible, or is it?
Actually, it is possible, but since we went through the multi-level parallelism, we thought that it's better to try actually asynchronous communication, because we know that asynchronous communications will improve the results of our commands, given the nature of our framework and how it works. So that's why we improved it with multi-level parallelism and then went to the asynchronism.
Okay,
but yes,
it's part of your incremental way of.
Exactly. Exactly.
Okay.
Because we had actually some limitations that we wanted to address, and this was the good way to address them.
Then a detail. Could you please go to slide 31? You have a graph on it.
Okay, 31.
31.
Sorry, because I don't have the same numbers.
Oh,
So this one.
Yes, yes. So here we see that isolation forest is very bad with an accuracy less than 0.7. Is it worthwhile keeping it in the experiment when you have such a bad pupil in the class?
We remove it basically. Yes. Actually, we kept it by purpose to show that even if actually we have some comatids or models that actually doesn't behave or doesn't show any improvement or anything, it doesn't impact the whole framework. Because it's true, it doesn't add anything, but for us it was important to show that whatever the choice of comatids or models, if some are working very good, it doesn't impact the whole framework, even if it's stagnant in the same accuracy. So that's why we kept it.
And if we go on, we could also say if one disappears, so it is related to fault tolerance, it's still robust. And
yes, exactly. That's it.
Yes, and so you used Super GCN framework.
Yes.
Could you tell what you thought about it? You used it on CPU.
Exactly.
Is it also available on GPUs?
Actually, we didn't try it. The Fuga doesn't have GPUs, only CPUs.
Okay.
So that's why I couldn't say. But yes, we used Super GCN that was actually done on Fugaku the first time, and we used it as a tool.
Okay. Were you pleased with the partitioning tool, or did you see things that could be improved in it? What's your feedback about that?
Partitioning, I think you are talking about the graph?
About Super GCN, about the tool.
Improving, I'm not going to say improving because it helps actually handling the strong scalability. It was thanks to Super GCN that we gained 52 times speed up. So I'm going to say that it was very good.
Okay. Very positive. Okay. It seems to me that in your PhD, use the kind of trial and error approach. Are there many experiments that you have carried out that are actually not shown in the document? Just to evaluate the amount of experiments that maybe you had to carry out and just to test, and that you maybe did not keep in your
you are talking about all experiences that I did, and yes, we did several. We used LSTM. We used actually combining graphs with random forest. We used different things, and we just kept the ones that improved the framework. When we talk about experiences, we had really, very, very, very large experiences.
Okay. Here you have a variable which is the category of attacks.
Yes.
But I guess what you are interested in is there an attack or not?
Exactly.
Would it be possible to do it simpler? If you just want to know if there's an attack or not, is it relevant to take into account the category?
Well, I'm going to say it's not really relevant because, as I said, attacks are sophisticated, so we can have a new malware family that we hadn't before. So it's not really for us, in our case, relevant. And also, we are doing something that will work, or we want it to work for every domain application. So just if it's benign or not, malicious or not. So that's why actually in our application, we didn't see that it's relevant, because we are not looking for a solution to, because in our SWAR, what I forgot to add, in our SWAR, we wanted to go until the remediation. So here, yeah, it's important, but at the end, we hadn't time to stop. So yes, when we are talking about remediation, it's important to know what malware family the attack came from.
I had a question about the data set you have used. Yes. So you have 12% of attack activities in it.
Yes.
And you have shown another slide where there's a different percentage.
Yes.
Don't show it.
Yes. Okay. Okay.
So what is realistic? Does it depend on the company, which is the target of the attack? When I read the document, I thought about this percentage, and I thought, okay, is it realistic, this 12%? If I don't know the creation date of this data set, if we would do it now, would it be much higher? What do you think about the percentage of attack activities in general?
I think, in my opinion, it's gonna increase, because actually cyber attacks are increasing. If we can say just before the COVID and after the COVID, they increased, they double or multiple times actually. So yeah, the data partition of malicious and benign attacks or benign instances, it will increase with time. So now, yes, we had 12%, and the data set, I think it's from 20, I don't remember exactly, but it's not really a new data set, but it's the biggest one, that's why we used it. But yeah, now I think it's gonna be a little bit more balanced, not really the balance, but it's gonna be easier.
I think you played everything. Thank you very much.
You're welcome.
Thank you, Fabienne. So
my turn. So the more it goes, the less question there are.
Okay, that's great.
It becomes repetitive. So
okay,
for the first time, I am also very happy with the quality of your work, and I also want to acknowledge the very good quality of your PhD and thesis and your defense. It's great. I come from HPC.
Okay.
Questions will be more HPC related. Okay. A general question somehow on what you mentioned, Fabienne, about when you mentioned the source and the sources.
Yeah.
Also, it came to my mind that the first part, the data sources, I assume that the content of the data are very related with the domain. Yes. I think, for example, the data you could use for cybersecurity at CEA might be very, very different from what we could use in a hospital.
Yes, true.
Do you have any idea on how indeed generalized is this model for all this? Because
yes,
quality of the data, balance of the data, exactly. Logs, no logs, also a different way to manage the information system.
Yes, I'm going to come back to the slide of scikit-learn, because it was somehow asked by Mr. Milab, because yes, actually, that's why we tried in our experiments to try actually supervised models with unsupervised models, but also semi-supervised models, actually to be working for or to be able to work or detect everything for healthcare or finance or whatever, actually leveraging the strengths of all of them and also the weaknesses, because we have some that have some limitations. So yeah, the fact that we combine all of them, we can, I'm going to say, ensure somehow that it could work for all applications, since we are combining all of them different. That's why we were actually focused on the heterogeneity of campaigns. We aren't just talking about the same nature of models. We are talking about really different nature of models. That's why actually we had some that took time and others that not, because really the heterogeneity was here. But we changed actually the models used.
I think also, maybe that was said already, sorry about that, but the level, the percentage of attack can clearly differ from one field to the other one.
Exactly.
I'm also discussing with CA guys, the level of attack, for example, differs here if you are using a Windows computer or Linux computer. So all of these biases can be addressed by
exactly. Exactly, and the higher the attacks we have, or the other class of the malicious class, the higher we have, it's the better the model will learn. Because when we don't have really attacks, or I'm gonna say malicious instances, we talk then about rare anomalies or rare events. Then it's very hard for the model to detect them or to know them, because it doesn't have enough time to know them.
Do you think we could
Yes.
We could use something, for example, an AI, because now also AI are actually making the attacks.
Yes.
Could we use an AI to prevent the next attack, like generate a new form of attack?
Yes, actually, I'm going to say that this is somehow what we want to do, but since we didn't really try it in real life with our SWAR, I'm not going to say that it's done or not, but this is what we want to do actually. To really, when we tried to learn to our model to know what's abnormal. So it learns, since we had imbalanced data, we told the framework to know what's normal data, and everything which is almost a little bit different of what's normal is detected. So this is what we are trying to do. It's really gonna work in real life or not, this is what we...
Something also that came to my mind, we talk about resilience. So if one model is out, yes, we could make a restart and a recreate, and it takes the last restarting thing.
Yeah.
Eventually, something that could be done is, if you start with 3 models in the lifetime, you need to improve, maybe add a 4th model ongoing during your first part.
Okay, that in the framework.
Yes.
Actually, we didn't add it. You mean
like during the execution, you start with
the
3
time
models,
this is with training, we can add. Actually, we never did this, but I think it's not something difficult to add actually, because we implemented the framework and then we choose in the main the models we want to use. So we can increase them, or we didn't really did the experiments, but we can do it because the model where the framework was implemented apart, it doesn't have any relation with the models or whatever. So really, it was implemented apart, and then we can change it. So, like we can say, models are just hyperparameters that we can change easily. It's not a problem.
And parallel, so I used to work on MERAM method.
Okay.
Something that's old, I know. Something that I remind is when you had the several methods, basically you had an equilibrium between the numerical parameter and the execution time, and basically it went.
Yes. Yes.
On some cases, you had really an equilibrium. If the one model was too weak, it could not converge because not numerically weak enough. And the other one, you put a high numerical precision, but then the execution time is very long, and you already have the equilibrium between the two. Is it something you find back here? This kind of having not something too different or too extreme between.
Okay. So in our framework, we didn't really have this because we are exactly inspired by Unite Vancouver, but the fact that we have backend boosting, actually the both actually, I'm gonna say it, but yeah, it doesn't show the fact that actually hyperparameters or numerical parameters was an effective. No, in our case, no, it wasn't the case.
This question for fun. Yeah. How easy it was to use Fugaku?
Oh, in the beginning it wasn't. Thank you. Thank you very much.
Thank you, France.
Oui, merci. Je vais me permettre de poser mes questions en français.
Ok, vas-y. Allez-y, pardon.
Tout le monde est francophone.
Oui.
Eric comprend de toute façon.
Oui.
Oui.
Tu as dit que l'hétérogénéité des cométhodes augmente la performance de UC2B.
Oui.
Et tu as suggéré que pour le modèle séquentiel de boosting, c'était mieux de partir de méthodes plus performantes et d'aller vers des méthodes plus faibles. Est-ce que c'est le même cas pour le modèle avec le multiparallélisme asynchrone?
Oui.
Comment tu organises les méthodes du coup?
Alors, comment on organise les méthodes, comme j'ai dit tout à l'heure, j'ai répondu à la question que en fait on le fait vraiment in a random way. Donc même dans le cas séquentiel, c'était in a random way. Mais j'ai dit que c'est mieux en fait si on va des plus fortes aux plus faibles, parce que le but du boosting, c'est vraiment rendre la plus faible forte en la boostant avec les autres qui ont été entraînés précédemment. Mais du coup, dans notre cas, comme on combine plusieurs modèles qui sont un peu différents l'un de l'autre, où il y a un modèle qui est capable de détecter des instances que l'autre ne va pas détecter. Donc cette combinaison, elle fait que, sans parler de l'ordre, et du coup, comme ils sont entraînés en parallèle, je pense pas que dans ce cas, l'ordre va changer quelque chose. Parce qu'il n'y a pas de boosting qui est à l'intérieur. Il y a le boosting après l'itération pour toutes les méthodes. Donc, de toute façon, le boosting se fait pour toutes les méthodes. Que ce soit on commence par les vite ou par les fortes, c'est la même chose.
Alors, je vais poser ma deuxième et dernière question en sortant un peu de la cybersécurité. Si j'ai des données médicales, par exemple, et que j'ai un autre processus à tester, là, tu as fait un travail de recherche intéressant en mélangeant des choses et en testant et en construisant un algorithme. Du coup, en utilisant ton algorithme parallèle, est-ce que si j'ai un nouveau cas avec un nouveau très gros dataset, qu'est-ce que tu conseillerais comme meilleure méthode, comme recette à faire pour aller vers les meilleures méthodes et notamment, vu que c'est un peu séparé dans ton manuscrit, est-ce que tu conseillerais de mélanger à la fois des méthodes de machine learning comme ce qu'on voit à l'écran là, et des méthodes de deep learning comme SuperJCN pour essayer d'avoir de la performance?
Ok, je me permets juste de vous dire que l'accueil il est en train d'appeler, donc j'espère que c'est pas grave.
Ok.
Donc pour répondre à la question, là, comme je vous ai dit, comme on a plusieurs co-modèles en fait, co-modèles, si par exemple on veut appliquer ça au domaine de healthcare, ce qu'on va faire, c'est en fait, on va choisir des modèles. Si déjà on a des connaissances par rapport aux données, comment elles sont, est-ce qu'ils sont bien structurés, semi-structurés ou pas structurés, ça nous permettra de faire un très bon choix des co-méthodes. Mais dans notre cas, comme je vous ai dit, en fait, on a essayé de combiner essayer de prendre des modèles qui sont forts, par exemple, en ça et pas. Ça dépend des données. Nous, on ne s'est pas concentré vraiment sur la nature des données qu'on a, même si normalement on a un dataset qui n'est pas équilibré et tout, c'était pas ce qu'on a vraiment pris en compte. On a essayé de faire quelque chose qui marche en même temps pour la cybersécurité et qui pourra aussi marcher pour d'autres choses. Et comme en fait le domaine d'application était la cybersécurité, pour nous, avec ces résultats, on peut dire que quand même ça a répondu à nos attentes. On pense que ça va marcher aussi en utilisant des méthodes qui se complémentent en fait, où il y a d'autres qui sont supervisées, d'autres qui n'ont pas supervisé. Mais comme je vous ai dit, ça dépend aussi des données qu'on a, de la quantité de données qu'on a. Si on a une très grande quantité de données, là, on peut aller aussi à augmenter le nombre de bagues qu'on a à l'intérieur pour utiliser aussi tout le nœud. Et ça va pas impacter l'apprentissage comme on a une très grande base de données. Voilà.
Ok, merci. Et merci de m'avoir invité.
Thank you, Marcel.
Oui, c'est peut-être ce qu'elle a entendu, sinon je ne sais pas.
So, to end this session, I have also some questions. Most of them were asked before, as I am the last speaker. I would like to thank you for this clear and dynamic presentation. Also, many thanks for the manuscript because it was scientifically very rich, but in the same time, it was really pleasant to read.
Thank you so much.
A bit long, but really pleasant to read. It's not too easy to merge two different fields with a very long literature because both have many contributions, especially these last years. But you did it very nicely. I really enjoyed the state-of-the-art part because it was really clear, and as I said, it's not easy to pick the most important methods for both, and the most impacting one, and also the most suitable ones with the cybersecurity. So it was very very instructive for me. I learned a lot.
Thank you. It's a pleasure.
Most of my questions were asked before. The imbalanced data, the scalability. I have one. I still have some little ones.
Okay.
The scalability relies mostly on the communication.
Yes, exactly.
So how the communications evolve with the number of nodes, and also how the I/O operations handling these communications are implemented.
Okay. So, talking about the communications, when we increase the number of chromatins, increase the number of communications, because the most we have of the chromatins, we have more communications, because we have more chromatins that we will communicate. About the input data and output data, you are talking about the communication of input data and output data, right? Then, actually, we send only the misclassified data. So the communications will be like, for example, a model 1 and this is model 2. So model 1 will say to model 2, these are the misclassified instances. So you have to give them a higher weight. With even if you didn't ask about this.
I am talking about the implementation. How these communications are implemented in your software.
They are. You are talking about the tools we used when you talk about software tool.
Yes, but the real implementation, how they what do you use to communicate to send this data?
We use MPI actually. Okay. MPI for Pi senders to communicate.
With which collective?
With which collective of MPI? Because we used MPI for Pi from Python. So. Which collective? I'm not sure. What do you mean by
it? And well, the communications are evolve with the number of the chromatins, but this evolution is linearly or what?
It's not really linearly. It's not proportional. So, for example, if we go for it depends on the misclassified instances, and it depends on the power of models. Because if we have a powerful model, for example, we will not have more or big instances, bag of instances that we will share. So it doesn't depend on the number of chromatins. It depends on the power of the model,
and also the data.
Yeah, exactly.
It wasn't clear for me which contribution is integrated into the software and which one is not yet.
Okay, so when you talk about the contributions, do you talk about the last contributions where we summarized? So you are talking about these contributions?
The last one.
Okay.
If we have to mention a case, the last one, the MVP one, the when you add the third layer of parallelism.
Okay.
Is it integrated into the software or not yet?
No, it's not integrated. No, it's not integrated to the software. So you can actually add the multi-level parallelism or the third layer of parallelism, and you cannot. It depends. It's just only data parallelism, so it's not really integrated with the software.
Also, considering the obtained accuracy and the acceleration you got, which is a significant result, is it worth considering the degree of parallelization and also the deployment effort on the parallel machine? Because to make these contributions useful for all the community, maybe companies are, interested in these such problems, don't have clusters to.
That's true.
to execute on 512 nodes.
That's true.
So, considering the obtained accuracy and acceleration, is it worth to parallelize that much?
I'm going to say if we are looking for something, for example, in application for cybersecurity, it's worth it. Because as I said, for a continued training, it's going to take only 15 seconds. But if we are talking about, for example, manufacturing, we don't really need a continued training. We can do an offline training in one node or two nodes, or just a normal machine, for example, just on my laptop, I have used 4 GPUs, and it was working on, for example, 2 or 3 hours. So it depends on the application. If we are talking about sensitive domain like healthcare or cybersecurity, it's worth it to have a cluster supercomputer. If not, no.
So you said also that you choose this this data and also this benchmark for the size of the data because your model will learn enough and but if you have more time, which benchmarks can you recommend to investigate to have, I mean, an exhaustive performance evaluation?
Okay. I don't have really a name of benchmark, but I would recommend to try it on a larger data set and more imbalanced, because this will challenge our framework to know if it really works for more imbalanced. This was really imbalanced, 12% of anomalies and 87 normal. It was really a big challenge. So I would push it more and see if it will gonna really work on, because the more we have a bigger data set and with less anomalies, the more it's realistic. So this is what I would do, or I would recommend. But we didn't find a data set with this requirements.
And the last one.
Yes.
From all your the perspectives of your work,
Yes.
which one seems to you, I mean, very quick to achieve?
The generalization, the last one. The federated learning is also quick, but the quick one, the faster one, and the more important one, in my opinion, is the generalization.
Thank you very much.
You're welcome.
So we can go for the debate session. We have to leave the. I'm sorry. I give the. Supervisor, I'm not used to this process. So maybe the supervisors have some comments to.
Oh, okay, yeah, sure.
Yeah. Okay. Thank you very much for your invitation. So yes, I think that we are really happy and honored to have this collaboration with the laboratory at Paris University of Quentin. So this project has come up with after development that we had since 2017, where we come up with a new methodology of filtering, and we have patented it, which is double mask filtering. And after this year, we started working on a firewall, a new generation firewall, and we did collaborations with the INRIA in the beginning, and we worked on algorithms with for this double mask filtering. And after that, we did have this conversation with Ahmed to working with for this new project. So I think we start to be specialized as a French tech company. We start to be specialized in cybersecurity. So the issue here is how to detect the attacks, and I think that there is a very big challenge for every company working on this on this work. So for this one, what we do usually for this kind of academic collaboration, we integrate afterwards. So today we are on a step for new generation firewall, and the object and the aim is to have an XDR, an extended detection and response. And as I said, Zineb is SWOR. Today we have 3 PhD and working with other also laboratory with Reneria, with Université Versailles-Saint-Quentin, and also with ANSI to come up with this XDR. So as I said, Mr. Darf in the beginning, so the problem of the data and the quantity of data is really a big challenge for us, and we are really happy to collaborate with also other companies that maybe have the same challenge, and to have increased the number of data, and so maybe 100 gigabyte or even more, because to detect attacks, especially sophisticated attacks, is really a big challenge, and where to put the sensitivity between having the false positive and also having the false negative. And this is really the challenge for every company working on the XDR. So there is many working on this, many companies in United States and few in France. But today this is really our big challenge for us. So and maybe I think that this is a new step, and thank you very much for your presentation. It is clear, and I think that there was a lot of work, there was a lot of stress also. I think until now, I suppose.
Exactly.
So I think that this is the first step for us to go ahead on working on this XDR, because our aim is also putting this for the IT systems, but not just the IT systems, but also for the IoT systems. Because I think even for the health domain, or also for the industrial domain, I think that the effect is really high, and could cost a lot for this domain. And we know the new and the attacks that have been done since a few months ago. Unfortunately, for hospitals, or also for the industry, like automobile industry, and I think that the effect is really very, very bad. So this is really our challenge. We didn't already have the right XDR yet. I said yet, maybe, and so I think that we continue working on this, and also our work is really to integrate this technological bricks that is done with our partners, and at the end we are really happy to also to collaborate with other company having the same. And thank you very much for this invitation, and also for the quality of questions, because I think that also they highlighted also some things to improve in our way to work. So I think that thank you very much for you.
Thank you. I would like also to say that I am agree with Mr. Ayadi that your presentation was very good, and you I think that you summarized very well your research work during this last 3 years. So I try to be short, and I would like to say that as you mentioned in your presentation, the efficiency of UC depends first to the function that defines the collaboration between co-methods or co-models, and second to the implementation. It's efficient implementation, parallel implementation, and exploiting the communication, especially asynchronous communication between co-methods. So I think that your results are very good with very simple function defining this collaboration. And I would like to have your opinion now that you have many experiments about this kind of method. What is your opinion about a function, a general function that defines this collaboration? General and perhaps more complex, more sophisticated function, because the function that used it's relatively simple.
Yes. So okay. So you are talking about my function that I use for updating the misclassified instances, right? I'm going to just show it here. So this is the function I used to actually give a higher weight to the misclassified instances. This was a simpler function I implemented, and actually with all the results we got, we only used 1.1 for misclassified instances and 0.9 for the well-classified instances. Actually, and even with this balance, which is actually so weak, it's just a very actually small change. It helps to have a good result. So in my opinion, for example, I'm going to say more hard and challenging applications, increasing a little bit these parameters will allow very better results. So this actually to come back to the function. Our function actually, if we want to simplify it, when we have the A is 0 when it's well classified and 1 is when misclassified. If, for example, we have beta plus, which is the factor that we will multiply by the well classified and this the misclassified. For example, let's suppose it's misclassified, so it's going to be a 0. So beta plus over beta 1 power 0 is going to be 1. So we will have only beta minus that we will multiply by our misclassified instances to give results. Otherwise, we will have this dot 0. So this is going to be 1 and b minus 1. If I'm sorry, this is equal to 1, so it's gonna b plus over b minus. So b minus will go with b minus, and we'll have only beta actually plus. To summarize, to say, because I just want to explain how we did this work quickly and to give actually our function. To summarize, we just got a very good result while slightly changing or increasing the number of misclassified instances to actually give a very good or can maintain a very good balance between the misclassified and the well classified instances. So what I can say that is that as I said, if we have more challenging, we can further change this parameter.
Okay, good. This is a good response, but just it depends on the data.
Yes,
it depends on
exactly.
Nothing about the models.
Yes, yes, exactly. In our case, we wanted to focus on data to actually keep the black box, the methods as the models as black box. But in other domains, we can go further and go change or more, even enhance the results and conditions.
This is what I wanted to
hear.
Yes.
Okay.
So I would like also say that the application of UC to anomaly detection, it's relatively complex. We have a very interdisciplinary domain, and these applications needs knowledge in linear algebra, in AI, and in HPC. So it's a difficult work. And we have to add also the application field, cybersecurity in this case.
Yes.
So I have to say that Zineb succeeded to work to conduct this PhD dissertation in only 3 years. It's very important because the work, it wasn't simple. It was complicated. And also, you know, she has, she was in the good conditions in the sense that she did her PhD in Wiener Flowship, C Flowship with the numerics company. So this is a very good situation, and numerics company was very good for you, and also you are a member of 2 laboratories. This is also a very good point, and you also had 6-month stays in Japan. So also this was a very good opportunity. Somehow, thanks to you, and thanks to Maison de la Simulation, CAA, and all of this is very good. But she passed. You know, it is difficult to adapt for each of these various environments. So she passed many times for this kind of adaptation, and this is difficult in 3 years, just in 3 years, because in addition to all of that, there is some administrative conference from graduate school. This is not easy. So for me, her work is very good in short time. It's so short time.
Thank you so much.
Bravo.